Hi everyone, this is Dr. Nak, and today we're going to be learning about how to solve systems of nonlinear equations. So let's first go with what is linear equation and what is nonlinear equations. So for instance, if you have 2x plus 5y equals to 10 or something like that, notice that exponent on the variables are both 1. Whereas nonlinear equation will look something like this. So maybe I could go 3x squared plus 5y equals to 7. So in this case, notice that the exponent is no longer 1. So that makes it nonlinear. So let me just spell that out. So this is an example of a linear equation. And this one is nonlinear. So in this section, we're going to be learning how to solve the systems of nonlinear equations in 3 different methods. First one is by graphing. Second method will be using the substitution method. And the third method is called the elimination method. So let's first start with solving systems of nonlinear equations by graphing. Here are the steps to how to solve a systems of linear equations by graphing. Step number 1, identify the graphs. Sketch and find the points of intersections if they even intersect. Second, graph the first equation. And step 3, graph the second equation on the same rectangular coordinate system, meaning graph the second equation on the same graphing paper. Step 4, determine whether the graphs intersect. Step 5, then finally find the points of intersections. And step 6, check to see whether each ordered pair is a solution to both equations. Let's take a look at example 1. Solve the system by graphing. Okay, so what is a system? First equation is x plus y equals 4. Second one is y equals x squared plus 2. Alright, so step 1, we need to identify each graph. So let's look at the first equation. That is a linear equation because exponent on x and y are both 1. So this will be a line. Alright, now let's take a look at the second equation. Now what is that graph going to look like? Yes, it's going to be a parabola. So let me just write that out. Alright, so next we're going to graph the first and the second equation on the same graphing paper. Okay, so let's first graph the line, which is x plus y equals to 4. Now, if I rewrite that, solving for y, we're going to have y equals negative x and then plus 4. So that means that we're going to have a negative slope of 1 in fact, and then the y-intercept is 4. So if I need to plot this, let me see, y-intercept is positive 4, so I'm going to go 1, 2, 3, 4, so graph better cross here. Now our slope m is, remember it was rise over run, so negative 1 can be written as negative 1 over 1. So I'm going to rise negative 1 unit. So from this point, I need to go 1 unit down. And then run is a positive 1. So I need to go 1 more unit over to the right. And then I'm going to make myself a final dot and then connect those 2 dots. So this is the graph of y equals, I should say x plus y equals to 4. Same thing as y equals negative x plus 4. But let me just write down the original ones. We got x plus y equals to 4. Alright, so we're done with the first one. Now let's try to graph the second equation. Y equals x squared plus 2. The graph of that is going to be a standard parabola, but you're going to have to shift that parabola 2 units above. Or if you didn't know that, then you can always make a XY chart if you want. So let me just make a little chart. So for this guy, I'm going to make X and a Y. So what value should we plug it in? Maybe -2, -1, 0, 1, 2. Okay, so when x is -2, then we're gonna have -2 whole quantity squared. Let me just write that out, huh? So y is -2 squared plus 2, which is 4 plus 2. It's gonna give us 6. So we're gonna have to plot -2, 6. And when x is -1, then we're gonna have -1 squared plus 2. So this is 1 plus 2. It's gonna give us 3. So we plot -1, 3. And when x is 0, we're gonna have 0 squared plus 2. So this is going to be 2. So we're gonna have to plot 0, 2. And when x is 1, 1 squared plus 2, which is 3 again. So here you're gonna have 1, 3. And when x is 2, we're gonna get 6. So we're gonna have to plot 2, 6. All right, so let's do it. So -2, when x is -2, our y value is 6. So I think this is 6 right here, is it? Okay, so let me just plot that. All right, now the next ordered pair is at -1, 3. So we got -1, 3. So it looks like we are here. And then the next one is 0, 2. And then the next one is 1, 3 again. And then 2, 6. All right, so it looks like our parabola is gonna look something like this. Hey, that's not too bad. That's pretty good for my drawing. Now, can you guys tell where the points of intersections are? So the two graphs intersect at, I don't know if you can see this color in red, this point and then this point. So let's just guess what that is. Okay, so that will be when x equals 2, what is that? -2. And then our y value is at 6. All right, and then this point of intersection here is when x is 1, and then it looks like y is 3. But keep that in mind. But anyways, what we just did was we just did step 1, step 2, and then step 3. And step 4, determine whether the graphs intersect. Yes, they do. And then find the points of intersection is step 4. So what we did was we just plotted out to be -2, 6 and then 1, 3. So now the last step is this. We need to check to see whether each ordered pair is a solution to both equations now. Okay, so first what we need to do is we need to let's take -2, 6. I'm running out of room. All right, and then we're gonna have to plug this into both equations. So if I plug this into the top equation, then we're gonna have -2 plus 6. That's that gonna equal to 4? I think so, so that checks. And then the next one is y equals, what's my y? Is 6. Is that gonna equal to x squared, which is -2 squared plus 2? What do you think? So this is gonna give us 4 plus 2, which is 6, so it checks. So therefore, -2, 6 is a solution. Okay, now let's go with the other point. Oh my goodness. Well, I'm just going to try to squeeze it in here. Okay, so the next one was 1, 3. All right, plug this into the first equation, and we're going to have 1 plus 3. Is that going to equal to 4? Yes, it does. And then plug 1, 3 into the second equation. So you're going to have to ask yourself, is that going to equal to x squared? So in this case, 1 squared plus 2? Yes, it does. All right, so in this case, therefore, our solution set is -2, 6, and then 1, 3. All right, so this is our answer. All right, let's take another example here. Example 2, solve the system by graphing. So what do we got? X equals to 6. And the second equation is x plus 3 whole quantity squared plus y minus 1 whole quantity squared equals to 9. So let's first determine what kind of graph that we can get out of this. So let's first go with the first one. X equals to 6. Please note that it is not a point on the graph, by the way. That is actually going to be a line, which is slope is 0 and the x-intercept is 6. So what are we going to get is this is just going to be a vertical line. All right. And then the second one, can somebody tell me what this guy is? Yes, it's a circle. And the centered at, in this case, negative 3, 1. And the radius is going to be 3. So let's graph those out. All right, so let's go with the first one, x equals to 6. That's a vertical line crossing at x equals to 6. So let me go with 1, 2, 3, 4, 5, 6. All right, so you're going to have to draw a vertical line involving this point. So here it is. So our graph is not y equals, it's x equals to 6. All right, now let's draw the circle. Centered at negative 3, 1, so x is negative 3. And then 1, so it looks like our center of the circle is going to be here. And the radius of 3. So what we need to do is from this point, you're going to have to go 3 units to the right and the left and then the above and then below from the center. So you're going to go, so maybe your graph's going to go past here. And then 3 units above, so that will be here. Your circle better touch that point. And then 3 units will be right here. And then 3 units down will be here. All right, so I'm going to do the best I can to draw the circle, so don't laugh. Hey, that's pretty good too. I'm on the roll today. All right, so this is the graph of, let me just bring it over here so you can see it. X plus 3 squared and then plus y minus 1 squared equals to 9. Now let's take a look at this. Do they intersect? Nope, I don't think so. So guess what? That means that there's no solution to this system. Okay, because where the graph intersect, those intersection points are the solutions of the system. So in this case, we have no solution. So I'm going to box this for the answer. Now, the set notation for the no solution, you can go curly bracket with nothing in it. Or circle with the slash in the middle. It doesn't really matter, but I'm just going to stick with the curly bracket with nothing in it. Okay, so now let's take a look at the substitution method. So how to solve a system of nonlinear equation by substitution. All right, step number 1, identify the graph of each equation and sketch. Step 2, solve one of the equation for one variable. Step 3, substitute what you just got into the other equation. And then step 4, solve. Step 5, substitute each solution from step 4 into one of the original equations to find the other variable. You're like, what? Right? Don't worry, we're going to do some examples in a minute. And step 6, write the solution as in an ordered pair. Step 7, check that each ordered pair is a solution to both equations. Not just one, you have to check both. Let's take a look at example 3, solved by the substitution method. So here's our system. First equation is x squared plus 9y squared equals 9. And the next one is y equals 1/3 x minus 3. All right, so let's look at the first equation, x squared plus 9y squared equals to 9. You saw when I say, that's a circle, but no, I don't think it's going to be a circle because of that 9 that's attached on y squared. Okay, so let me just divide everything through by 9. then do you see that we're gonna have x squared over 9 and then plus y squared. If I'm gonna divide it by 9, then you're gonna have over 1 equals to 1. All right, so what kind of figure is that? Is an ellipse. Okay, so this graph is gonna be an ellipse. Major axis is gonna be parallel to the x-axis. All right, now let's take a look at the second one. All right, we got y equals 1/3 x minus 3. Yes, this is a linear equation, so this graph is going to be a line with the y-intercept at -3, with the slope is 1/3. All right, let's graph them. For the first equation, we know that it's going to be an ellipse, and I forgot to write, this is going to be centered at 0, 0. And the major axis is going to be parallel to the x-axis. So let me just write it as center. All right, so our center is going to be here. And then the major axis, which is the longer axis, is going to be parallel to the x-axis. So in this case, x-axis itself. Now, how much do I need to go along the x-axis is 3. Because look at what's under x squared. That value is 9. So from the center, you're going to have to go square root of 9, which is 3 units to the right, and then to the left. And then now, under the y squared, there is 1. Now, what's the square root of 1? That's 1. So that's telling you that from the center, you're going to have to go 1 unit above and then 1 unit below. And those are the points that where the ellipse is going to touch. So let me just plot that out. The first one is here and then there, right? And the y squared over 1, so we're going to have to go 1 unit, 1 unit. All right, so now let me try to connect those dots. All right, so this is our graph of x squared over 9 plus the y squared over 1 equals to 1. All right, so now let's go with the line. So we have 1/3 x minus 3, so the y-intercept is -3. That's where the graph is going to cross the y-axis. So let's go with 1, 2, 3. Wait, hold on. 0, 1, 2, 3. Okay, sorry, it's right here. All right, so this is when y is -3, and the slope is 1/3. So you're going to have to go rise 1 unit and then run 3 units to the right. 1, 2, and a 3. Now I'm going to make myself a dot. Then you're going to have to put a straight line through. And please pretend that that line is touching this dot right here. I'll just make it fatter. All right, but anyways, this line right here is y equals 1/3 x minus 3. Now, I just graphed it out very precisely, but can you tell what the answer is going to be? Do they intersect? No. So our answer should be no solution. All right. But now what we're going to do is we're going to prove that pretty much by using the substitution method. So I'm going to go to the next page. When we go back to this, do you see that our graph that we graphed it out earlier, they did not intersect? So that makes sense. So I just recopied the problem here. Okay, so now what we need to do is this. Since we're doing this by the substitution method, you're going to have to pick either one of the equation and solve for either one of the variable. If I were you, never ever solve for something has x squared or y squared. Always try to pick the equation or the variable that only has a power of 1, like such as x equals and then or y equals. Okay, so in this case, the bottom equation, it's already been solved for y. All right, so now what I'm going to do is I'm going to substitute that value of y into the top equation. All right, so then let's see what's going to happen. So I'm going to keep this guy as y equals 1/3 x minus 3. So I just solve for y from the bottom equation, and I'm going to plug that into the top equation. so which is x squared plus 9y squared. So now we're going to have 1/3 x minus 3 whole thing squared equals to 9. All right, so then let's keep solving this. So this is same thing as x squared plus 9. Now be careful right here. 1/3 x minus 3 whole quantity squared means we're going to have to go 1/3 x minus 3 times by the 1/3 x minus 3. So you're going to have to FOIL. Okay, so the first term, if I multiply this together, what do we get? 1/9 x squared. And then if I multiply 1/3 x with the minus 3, we're going to have, what do we have? Negative just 1x. Now let's go with the inner term. So inner term is going to be another minus 1x. And our last term, negative 3 times negative 3, that's going to give us positive 9. Combine the like terms. I could combine negative x minus x to make that into a minus 2x. So I'm going to rewrite it as 1/9 x squared minus 2x and then plus 9. All right, so let me replace that. I don't know why I changed the colors all of a sudden. But anyways, so that portion is going to become right here. So you're going to have 1/9 x squared minus 2x and then plus 9 equals to 9. All right, let's take one step at a time. Now what I'm going to do is I'm going to distribute this 9 to each term in the parentheses. All right, so then what we're going to get is x squared plus 9 times 1/9 x squared will just give us x squared. And then if I distribute, sorry, I'm just doing this. And then I'm going to distribute the 9 to minus 2x. So what do we get? We're going to get minus 18x. And then I'm going to multiply 9 times 9, which is 81, equals to 9. All right, so now let's see where it's going to take us. So this implies that I could combine these two. So we get 2x squared. And then we have minus 18x. And then what I'm going to do is I'm going to bring the 9 on the left-hand side by subtracting 9 on both sides. So let me just do that. Minus 9 and then minus 9. And I'm going to set the right-hand side to be 0. 81 minus 9 is 72. So I'm going to have a plus 72 equals to 0. All right, now let's try to factor. So I do have a greatest common factor of 2, so I'm going to get that one out. So it will be simpler for me to factor if it's factorable. So you're going to have x squared minus 9x and then plus 36 equals to 0. All right, so that's same thing as 2 times, or let's see if this is even factorable. So I better have an x and an x. And both sign better be minus minus. Now let's take a look at the two numbers whose product is 36. 1 times 36 is definitely one of them. And then 2 times 18. And then 3 times, what is that? 12. 4 times 9. 5 is not going to go in. 6 times 6. And now if I check, let's go with the first two numbers, 1 times 36. If I plug it in 1 and 36 here, is it going to add up to minus 9x? Nope. What about 2 and 18? 2, 18. When I add those two, am I going to have a minus 9x? No. 3 and 12? 3, 12? No way. 4 and 9. 4 and a 9? Nope. It's not going to add up to minus 9x. 6 and a 6? No. So this guy is not factorable. So if it's not, I usually try to apply the quadratic formula to see what the heck is going on. All right, so I'm just going to say this is not factorable. So if I really want to see even if I can solve this equation, I'm just going to go with the quadratic formula. Okay, so let me just write down. I'm going to apply quadratic formula. 2x squared, and then minus 18x, and then plus 72 equals to 0. So in this case, our a is 2, b is negative 18, and then c is 72. So our x is going to be minus b, plus or minus the square root, b squared minus 4ac, whole thing dividing by 2a. All right, let's plug and chug. So this is going to be minus 18, so it's going to be positive 18. I'll just write every step out. And then plus or minus the square root of negative 18 squared, and then 4 times a is 2 times c is 72. All right, whole thing dividing by 2 times a, so 2 times 2. Okay, so then I could simplify this to 18, and then plus or minus square root of negative 18 squared, what is that? 324. And then minus 4 times 2, 8 times 72, 576. Uh-oh, do you see what's going to happen here? Whole thing dividing by 4. All right, now let's look at the discriminant. Discriminant is who sits inside of the square root. Now, do you see that this value is going to be negative? Which implies that we're going to have an imaginary solution to this. In fact, I could just go 18 plus or minus the square root of 324 minus 576 minus 252. Whole thing dividing by 4, so this is 18 plus or minus square root of 252, and then I, whole thing over 4. I'm not going to even simplify that. That point is that we're going to have an imaginary solution, and in that case there is no solution to this. All right, so that implies that our answer is going to be no solution. Okay, so hopefully you caught that one on. So first what we did was we tried to solve the system by substitution. So we plugged y equals 1/3 x minus 3 in here, and we foiled it, distributed it, simplified it. So this is our simplified version of it. And what I try to do is I try to factor. So first I got the greatest common factor out, and then when I try to factor, I realized that, oh, it is not factorable. So I just wanted to see what's going on by using the quadratic formula, and if I use that, our result was to get the imaginary solution. So in this case, our answer is no solution, which is curly bracket with nothing in it. All right, so that should make sense. All right, let's do another example. Example 4, solve the system by the substitution method. So what do we got? The first one is 9x squared plus y squared equals to 9. And the second equation is 3x plus y equals to negative 3. So before we do anything, let's try to figure it out what kind of graph that we can get out of it. So let's go with the first one. It kind of looks like the previous example that we did. So I'm going to divide everything through by 9, and then what we're going to get is x squared plus y squared over 9 equals to 1. And x squared is same thing as x squared over 1. So again, this is going to be an ellipse. And the major axis is going to be parallel to the, which number is bigger? 9, right? And 9 sits under the y, so major axis is going to be parallel to the y-axis. And this guy is going to be centered at 0, 0. All right, now let's go with the second one. Okay, well, second one, notice that both degree on the x and y, they're 1, so for sure this is going to be a straight line, which is linear. All right, now let's take a look at both equations. Now what we need to do is we have to pick either one of the equation and then solve for either one of the variable. Try not to pick something that has x squared or y squared on it. All right, so if I were you, I would choose the second equation. Yes, I can solve for x, but isn't that y, solving for y, much easier? Because all you have to do is add 3x to the both sides. So that's what I'm going to do. So I'm going to take the second equation and I'm going to try to solve for y. So how do I solve for y? We have y equals, if I add 3x to both sides, then we're going to have 3x and then minus 3. All right, so let me just box that. All right, now what I'm going to do is I'm going to plug this y value into the equation that we have not touched, which will be the top equation. So I'm going to take the top equation, so this is the equation, 9x squared plus quantity 3x minus 3 squared equals to 9. So again, be careful. If you gotta go 3x minus 3 squared, so that means 3x minus 3 times by 3x minus 3. So here what we're gonna get is 9x squared and then minus 9x minus 9x and then plus 9, which equals to 9x squared and then minus 18x and then plus 9. All right, so this is what we get. So this is same thing as 9x squared plus, now we have 9x squared and then minus 18x and then plus 9 equals 9. Now let's simplify a little bit. Then this is same thing as, I can drop that parentheses, so you got 18x squared and then minus 18x and then plus 9 equals to 9. Now what I'm going to do is I'm going to subtract 9 from both sides and make the right hand side equal to 0. So then what do we got? 18x squared minus 18x. Oh, look at that. That's going to cancel out to be 0. So this is going to equal to 0. Alright, so now let's factor. So what can we factor? What's the greatest common factor? I think that's 18x. I could factor the 18x out. And the rest of it is going to be x minus 1. That works. So that's going to equal to 0. So that implies that either 18x equals to 0 or x minus 1 has to be 0. Now for the first one, dividing by 18, then we're going to have x equals to 0, and adding 1, you're going to have x equals to 1. So these are our proposed solution. All right, so now let me just box that because they're kind of important. Now we got the proposed solution for x. Now let's compute the corresponding y value when x is 0 and then also when x is 1. So let's first go with when x is 0, what is going to be our corresponding y value? So what I'm going to do is I'm going to plug x equals to 0 into this equation here where we solve for y already. Okay, so then what we're going to get is y equals to 3 times x minus 3, but x is 0, and then minus 3. So it looks like our y value is going to be 3 when x is 0. So our proposed solution right now is 0, negative 3. That's one of them. Now let's check for the corresponding y value when x is 1. Do the same thing. We're going to have y equals 3 times 1 and then minus 3, so that will be 0. So it looks like another proposed solution is when x is 1 and then y is 0. Alright, looking good, but we have to check. Alright, so let's check to make sure they're both are solutions or not. So let's first go with taking the first ordered pair, which is 0, negative 3. Now you're going to have to plug this back into both equations to make sure that it's going to satisfy both equations. So let's first plug this into the top equation, and we're going to have, let me see, what do we got? 9x squared, so it's going to be 0 squared, and then plus y squared, which is negative 3 squared. Is that going to give us 9? So this is what we need to check. So what do you think? 0 squared is 0, and then negative 3 whole quantity squared is 9, and 0 plus 9 is 9, so it checks. All right, so that's from the first equation. Now let's go with the second equation. You're going to have negative 3 times x, which is 0, and plus y, which is plus negative 3. Is that going to give us negative 3? All right, so let's check. We have 0 and then plus negative 3. And yep, it goes to negative 3. Great. So an ordered pair 0, negative 3 satisfied both equations. Which equations? The original equation that I'm talking about. So therefore, we get to keep that 0, negative 3 as a solution. So 0, negative 3 is a solution. All right, we're not done yet. We still got to check that other ordered pair, which is 1, 0. All right, now again, we're going to do the same thing. We're going to plug it in, 1, 0, into the original equation. We're going to first start out with the top equation, and then we're going to plug that 1, 0 to the bottom equation. All right, so then what do we get? We're going to have 9x squared, which is 1 squared, and then plus the y squared. Is that going to give us 9 back? I think it's yes, because here we're going to get 9 plus 0, which is 9. So it checks. All right. And then for the second equation is negative 3 times x, which is 1. And then plus y, which is 0. Is that going to give us negative 3? I think so, because this is negative 3 plus 0. Last time I checked, that's negative 3. Great. So guess what? We get to keep both of them as a solution to this system. So let me just write down the final answer. So therefore, our solution set is 0, negative 3 and 1, 0. Now, I forgot to graph this out earlier, so let's try to graph it out and make sure our graphing solution and the solution we just got by using the substitution method makes sense. All right, so let's try to graph up the first one, which is going to be an ellipse. Centered at 0, 0, major axis parallel to the y-axis. So the longer axis is going to be the y-axis. Now how much do I need to go up and down from the center is square root of 9 units, which is 3 units. I'm going to go 1, 2, 3. So my parabola is going to touch here, 1, 2, 3. All right, now our minor axis is going to be parallel to the x-axis. Now how far do I need to go from the center to the right and left? It's just 1 unit. And let me just draw this out, graph this out, I meant. All right, so this is our equation. X squared plus y squared over 9 equals to 1. Now let's graph the linear equation. So in this case, we have a y-intercept at a negative 3. And then slope is 3 over 1. Right, so I'm going to go 3 units above and then over 1. And I'm going to connect those two dots to draw the straight line. All right, so where's the points of intersection? I see one to be here. So this point right here would be when x is 1 and then our y is 0. And I also see another point of intersection here. In this case, our x value is 0 and then our y value is negative 3. So does it match up with the answer that we got by solving the system by the substitution method? Answer is yes. So we did it right. All right, so now let's go over the elimination method. So here are the steps, how to solve the system by the elimination method. Step 1, identify the graphs of each equation and sketch. Number 2, write both equation in standard form. That means that you want to write it in terms of ax plus by equals to c or something like that. All right. And then step 3, make the coefficient of one of the variable opposite by deciding which variable you want to eliminate. Step 4, add both equations. And 5, solve. Then you're going to substitute each solution that you got from step 5 into one of the original equation and write each solution as an ordered pair, and then check your solution to make sure that your proposed solution satisfies both equations. You're like, oh my gosh, what is going on? It's not as bad as you think. So let's, I think the best way to do this by the example. So let's take a look. Example 5, solve the system by the elimination method. So our system, the first equation is x squared plus y squared equals to 9. So this is nothing but a circle centered at 0, 0, and the radius of 3. All right, now let's take a look at the second one. Well, isn't this nothing but a parabola? Because I could go, hold on, let me just write parabola. Because I can solve for y, and then I can get, let me see, y equals x squared minus 9. All right, so this is going to be a parabola centered at 0, 0, and then you're going to shift that whole entire parabola 9 units downward. All right, but anyways, so if I sketch the first one, circle at centered at 0, radius of 3. So our circle is going to look like this. All right, and the parabola centered at 0, 0, but you're going to have to shift that 9 units downward. Now, again, if you don't feel comfortable, just make yourself an XY chart. So I'm just going to write it right here, X and a Y. So let's go maybe with -2, -1, 0, 1, 2. I think that should be enough. So we have, when x is -2, our y is -2 squared minus 9, which is 4 minus 9, which is -5. I'm running out of room here, so I need to plot -2 comma -5. And when x is -1, you're going to have -1 squared and then minus 9. So that will be +1 minus 9, which will be -8. So you're going to have -1 comma -8. When x is 0, that one's easy. Y value is -9. So I need to plot 0 comma -9. And when x is 1, you're going to have 1 squared minus 9. So again, this is going to be -8. And when x is 2, we're going to get 2 comma -5. I think you saw the pattern already. All right, so let me just plot these out. So we got -2 comma -5. -2, 1, 2, 3, 4, 5. So that will be here. All right, and then -1 comma -8. Am I going to have enough room? That's -5, 6, 7, 8. Let's make that into a 9. All right, so then here, let me see. -1 comma -8. -1 comma -8. And then 0 comma -9. Oh no, we're at the very, very bottom of the page. And then we're going to have, which one's next? 1 comma -8. And then 2 comma -5. So the parabola that we're going to get is something along this line. This is just a sketch. Oh my gosh, this is just a sketch. I have no idea where it's going to intersect. That's why I'm going to try to solve this by using the elimination method. But anyways, let's take a look at the two equations. Now, what do they have it in common? Well, I see that we have x squares in common. So what I'm going to do is this. I want to try to get rid of the one of the x squared by multiplying either the top or the bottom equation by -1. So that way when I add those two equations together, x squared will disappear. So let me continue on the next page. Go back. Okay, so let's take a look at what we just drew earlier. So first it looks like, remember this is a sketch. This is just like completely drawn off the scale, especially the way I draw it. You should know this by now. So it looks like it's gonna intersect. So what are they intersect again? All right, so what I'm gonna do is doesn't matter which equation that you're going to take, but let me just take the bottom one and I'm going to multiply that guy by -1. If you're going to multiply by -1, you better multiply -1 on the right hand side of the equation as well. So let me rewrite. So if I rewrite the whole system, then I'm going to have x squared plus y squared equals to 9. Then negative x squared plus y equals to -9. All right. Now the next step, if I add them together, do you see that our x squared is going to disappear? That's exactly what we wanted. Now, who's left over on the left-hand side of the equation? Well, we have y squared plus y, and then equals 9 plus -9, which is going to give us 0. All right, so from here, let's try to solve for y by factoring, maybe. So I could factor out the y, and we're going to have y plus 1 in the parentheses equaling to 0. That implies that either y is 0 or y plus 1 is 0. So that implies that y is -1. So let me box that. All right, so we got two possible answers for y. Now what we're going to do is we're going to get the corresponding x value when y is 0 and y is -1. Now, in order to do that, it does not matter which equation that you're going to take. I'm talking about the original equation. So, you know what? Which one looks cuter to you? To me, the bottom one looks a little bit more cuter, so I'm just going to pick the bottom one. So I'm going to pick x squared minus y equals to 9, and I'm going to plug it in when y is 0 to compute the corresponding value for x. Then if I do that, then you're going to have x squared minus 0 equals to 9, which is x squared equals to 9. Now be careful on the next step. Remember, when you take the square root, your x is going to be plus or minus the square root of 9, which is x equals plus or minus 3. So this is telling you that when y is 0, x is 3, and x is -3. So let me just make that into an ordered pair. So here is our proposed solution, a point I should say. So you have when x is +3, y is 0. And when x is -3, our y is 0. So let me just box this and then we'll check our solutions later. All right, now we're going to do the same thing for y equals to -1. Now if I plug that into x squared minus y equals to 9, we're going to have x squared and then minus -1 equals to 9. So that implies that we're going to have x squared plus 1 equals to 9. So that means that we're going to have x squared equals to 8. So that implies that our x is going to be plus or minus the square root of 8, which is, simplify all the way, x is plus or minus 2 square root of 2. So this is telling you that when y is -1, our x values can be either 2 root 2 or the -2 root 2. So you're going to have 2 root 2 comma -1 and -2 root 2 comma -1. So we have 4 proposed solutions now. All right, I know it's a pain in the butt, right? So now, last thing, what we need to do is we need to check. So, all right, we got this. All right, so check. Let's first check 3, 0. Now I'm going to plug this into both equations. In fact, the original equation. Okay, so if I take the original equation, then I'm going to get 3 squared plus y squared, which is going to give us 0 squared, equals to 9. Does it equal to 9? Yes, 9 equals to 9, so it makes sense. All right, now let's plug this into the bottom equation. You're going to have x squared, so you're going to have 3 squared, and then minus y. Is that going to give us 9? Yes, it does. All right, so 3, 0 is a keeper, so we're going to keep this one. All right. Now let's check who's next. -3, 0. We're going to do the same thing. I'm going to plug this into the original equations. And here you're going to have x squared, so which is -3 squared plus 0 squared, y squared, does it gonna equal to 9? Yes, it does. And then the second equation is x squared, which is negative 3 squared, and then minus y, which is 0. Is that going to give us 9 back? Yes. All right, so therefore, negative 3 comma 0 is also a keeper. All right, we can do this. Two more checking. All right, so check. Let's go with 2 root 2 comma negative 1. All right, we're going to plug this into the first equation. So our x is x squared. So we're going to have 2 square root of 2 squared, and then plus y squared, which is negative 1 squared. Now, is that going to give us 9 back? Okay, so let's take a look at this. So remember that exponent 2, this little exponent 2, is going to distribute to this 2, and then also to the square root of 2. So this is basically the same thing as 2 squared times the square root of 2 squared. And then, whoops, and then, oh my goodness, what is that? Squared, and then plus positive 1. Is that going to equal to 9? So let me just check over here. So 2 squared is 4. And then root 2 squared is 2. And then plus 1. Is that going to give us 9? I think so. Excellent. So we get to keep 2 root 2 comma negative 1 as a solution as well. All right, one more. Check. Negative 2 root 2 comma negative 1. I think this is going to satisfy because we're squaring both x values and y values, right? But let's just double check. All right, so then you're going to have negative 2 root 2 squared, and then plus negative 1 squared. Is that going to give us 9 back? I think so, because this is same thing as negative 2 squared times the root 2 squared, and then plus negative 1 whole quantity squared is 1. Is that going to equal to 9? So negative 2 whole quantity squared is again 4. Root 2 squared is 2. And then plus 1. Yes, it's going to equal to 9. So it satisfied the first equation. Now let's go with the second equation. So the second equation is x squared, which is negative 2 root 2 squared, and then minus the y. So minus 1. Is it going to give us a 9 back? All right, so let's check. This is same thing as negative 2 squared, root 2 squared, and then plus 1. Is that going to equal to 9? All right, so let's check it out. So negative 2 whole quantity squared is 4. Root 2 to the second power is 2. And then plus 1. Yes, it's going to equal to 9. So guess what? We get to keep all of them as our solution set. So you got negative 2 root 2, comma negative 1. They're all going to be the solution to our system. So I don't even know where to write the answer, so I'm going to write it at the top. So therefore, our solution set is 3 comma 0 and negative 3 0. And then 2 root 2 comma negative 1, and then negative 2 root 2 comma negative 1. So this is going to be our solution. Here we go. All right, so let's go back to the graph that we sketched earlier. Well, I kind of erased the parabola part, but if you remember that since I just sketched it out, I was not sure where the parabola and the circle was going to intersect. But according to the elimination method, we had 4 points of intersections. All right, so the first one was 3 comma 0, and then negative 3 comma 0. So that will be here. That means that our parabola is going to touch the circle at these 2 points for sure. All right, now they should also touch at 2 root 2 comma negative 1. If you type in 2 root 2 in the calculator, it should be approximately 2.8. So 2.8 will be like maybe here, and then negative 1. All right, and then the next one, it will be negative 2.8. So negative 2.8, it's kind of close to negative 3, comma, negative 1. Which will be, so let's pretend this is negative 2.8, comma, negative 1. is here. So it's the way I drew it, since the grid is kind of small, it was really hard for me to believe that it's going to intersect at 4 points. But in fact, we just proved that in fact it is going to intersect at 4 points, so that our parabola are going to have to go through these 2 points and then also hit all these points that we plotted out earlier. Oh my gosh. All right. You know the way I draw. So here it is. All right, so I'm going to stop here. Again, if you have any questions at all, please let me know. And great job, everyone. I'll talk to you later.